Okay, so you've probably seen those gigantic tires on mining trucks and other massive industrial machines. But here's something you've likely never considered. What you're looking at isn't just a big piece of rubber. It's actually a high-pressure vessel, and safety standards treat it with the same kind of caution they'd use for, well, for a bomb. And today, we're going to find out exactly why.
It seems like a strange question at first, right? I mean, it's just a tire. How complicated can it possibly be? Well, the answer is locked away in a world of incredible stored energy and absolutely catastrophic risk. This safety manual, this whole system, it exists for one simple reason: to prevent a failure so sudden and so violent, it can be just as deadly as any industrial explosion you can imagine. So let's get right to the heart of it. What is it that makes these tires so uniquely dangerous? It really boils down to a simple mix of physics and massive scale that transforms a regular old piece of equipment into something that has to be handled with extreme care. Now, the safety standard we're looking at has a very specific starting point. It kicks in for any tire and rim assembly that's 24 inches or larger. So right away, we're not talking about your car tires. We are firmly in the world of massive, heavy-duty machinery where everything gets scaled up, especially the danger. But here's the real key, the thing you have to understand. While the size is super impressive, the real danger comes from the insane amount of air pressure needed to support these multi-ton vehicles. All of that compressed air, it stores a terrifying amount of kinetic energy. And if that energy is released all at once, it's not a pop, it's an explosion. It's a bomb going off. And the results of a failure like that, they're just devastating. We're talking about a violent explosion that can launch heavy metal parts of the rim like shrapnel. The safety manual lays out entire systems to deal with the risks of fires, to control a tire that might fail and start moving on its own, and to protect people from the unbelievable crushing force of these giant assemblies. If you want a real sense of the respect this kind of energy demands, just think about this. During inflation, which is one of the most dangerous moments, the standard requires a 5-meter exclusion zone. That's over 16 feet. No one is allowed inside that zone. And that's not a suggestion, it's a hard and fast rule designed to save lives. So how in the world do you manage a risk this big? Well, you definitely don't just wing it. You build a system. You build a master plan. And that's really what this standard is. It's a master plan for taming this incredible force. A whole set of interlocking procedures designed to see a failure coming and stop it before it happens. The very foundation of this entire safety system is something called the risk register. Now, you can think of it like a complete library of every single thing that could possibly go wrong. I mean everything, from choosing the right tire in the first place to getting rid of it at the end of its life. Every single potential hazard is identified and a specific control is put in place to manage it. Okay, but what if you run into a situation that isn't in the playbook, something that's not routine? Well, that's where the Job Safety Analysis, or JSA, comes in. If a new piece of equipment shows up or a procedure has to be changed for some reason, a JSA has to be done. It's basically a dynamic risk assessment, making sure that even the one-off, non-standard jobs are done with the exact same level of systematic safety. All right, let's look at how this master plan actually plays out on the ground, in the real world. The standard is packed with super specific, non-negotiable procedures for all the most critical tasks. And of all of these rules, there is one that's held up above pretty much all the others. It is an absolute, ironclad prohibition, and it has to do with one of the most common activities you'd find in any heavy-duty workshop. You never, ever, under any circumstances, apply heat to an inflated tire assembly. No welding, no cutting, nothing. You see, heat makes the pressure in a closed system, like a tire, skyrocket. Doing this is literally like lighting the fuse on that bomb we talked about. The procedure is crystal clear. If you absolutely have to apply heat, the tire, and if it's a dual set, its partner too, has to be completely 100% deflated first. That same level of precision carries right on over to removal. First, a visual inspection. Then, the tire is deflated down to just 5 psi or less, and only then are the fasteners loosened. That sequence is absolutely critical. It makes sure that all of that stored energy is let out in a controlled, safe way before the wheel is ever physically taken off. And as you'd expect, inflation is just as strict. First, every single component is checked to make sure it's compatible. Then, the whole assembly gets put inside a restraining device, like a heavy-duty steel safety cage. The inflation itself, it's done with a remote system. The operator is standing safely outside that 5-meter zone, watching the pressure gauges and making sure the wheel is seating properly from a safe distance. But Safety cages, strict rules, remote controls, they're only as good as the people who are using them. And this standard puts a huge emphasis on the human element because it recognizes that real expertise is the final and maybe the most important layer of defense. So what does it actually mean to be a competent person in this context? Well, here's the standard's formal definition. You can see this isn't just a casual term. It's a formal qualification. It's a mix of training, education, and real-world experience. In this line of work, being competent isn't just about being good at your job. It's a documented, verifiable requirement. And all of this creates this amazing ecosystem of safety. You've got these highly trained, competent people using tools like pressure gauges and torque wrenches that are regularly maintained and calibrated. They get periodic hazard awareness training. And get this, every single tire and rim has a unique ID, so its entire history, from the day it was made to every inspection it's ever had, can be tracked. It's a system where people and equipment all work together. So after looking at all of these rules and registers and step-by-step procedures, what's the big takeaway here? Why does all of this meticulous, sometimes tedious detail matter so much? Because at the end of the day, these aren't just bureaucratic rules on a page. They are a shield that's been carefully built from the foresight to see every possible risk, the discipline of a procedure to control it, and the expertise of skilled people to make it all work. It is a system designed to protect lives by deeply respecting the incredible power that's hiding in plain sight. So the next time you see a piece of heavy machinery, you won't just see a giant tire. You'll see this incredible, hidden world of complexity that's required just to keep people safe. And it really makes you wonder, doesn't it? What other everyday objects out there are governed by a secret world of life-saving rules we never even see?